After learning about these basic sorting algorithms, let's see how can we search for an item in an array. And let's understand the worst case time complexity of searching for an item in an array. Let's start with an unordered array, which is basically the one in which the elements of the array are unsorted. They can be in any random order. Now, accessing an array element through its index is very fast, alright? Because when we reference an array, we basically have the address of the first element. And going to any other element is very fast. Just by adding the index number as an offset to the first element's address, we get the new address and the element can be accessed through that. So accessing array elements like this does not really depend on the size of the array. And we say that accessing array elements through their index is a constant time operation, which we write as O1, alright? But what if we want to search for an element without knowing its index? For example, what if we want to find the number 8? What would be the worst case time complexity of this operation? Think about it. If the elements of the array are not in any particular order, we will have no idea where 8 is present. It may be at the 0th index or the last index, who knows? So the best strategy would be to start from one side, let's say starting from the 0th index. We access the elements one by one and see if the element at that index is equal to what we are looking for. And if the element is found, maybe we return the index of that element. In the worst case, what may happen? The element is not there in the array at all, or probably it is the last element of the array, which means that we will have to go through all the array elements before we can figure that out, right? So that means in the worst case, it will take time proportional to the size of the array to be able to find the element or say, well, it's not there. It is just like the case where you go into a library to find your book and there is this large bookshelf with a whole lot of books in it. And unfortunately, someone has messed it up and the books are not kept in any order. So if you have to find your book, let's say we are looking for the book Growing Through Divorce. So we start from the left and keep checking each book one by one until we get to the book we are looking for. So we say that finding an element in an unordered array takes order of n time in the worst case. And what about deleting an item? Well, delete also takes order of n time because we should first find the item and then delete it, alright?